Hi, 8th graders. Today's lesson is lesson 1-7, words, equations, tables, and graphs. Now, this is something we're actually going to use now until almost probably April. We use a lot of the stuff we're going to learn in this lesson. So a lot of the things we do branches off of this, so we have to have a good base of this before we move on. So make sure if you have any questions, write them down, highlight them, something, so I can talk to you about them tomorrow or the next day. So the first thing I'm going to talk about is an equation and what it is, okay? So an equation is a mathematical sentence stating that two quantities are equal. You actually deal with equations quite often, even when you're young. I mean, this can be a simple equation. Okay, that you see how two things are equal. This side is equal to this side. And a lot of times when I talk about this, a light bulb kind of goes off for the 8th graders. And I think, oh, I never thought that 3 plus 1 equals 4 on the other side. They never think that the one side is equal to the other side. But in reality, that's what you're doing. You're making one side equal to the other. This is another type of equation. Okay, this is an equation. There's a whole bunch of equations out there. So anytime really that anything has an equal sign, for the most part, is an equation. Now equations, if you look below here, equations can be expressed in 4 different ways. And this is found on page 38 of your book, if you happen to have it open by chance. Yeah, equations can be 4 different ways. And a lot of times we just think of it as this, but we don't think of it as the other 3. Like words would be like the sum of a number and 3 is 9. What's the number? That's an example of a word type of equation. Okay, equations, the other thing, kind of what I talked about here. Okay, equation. Now tables and graphs, you're lucky because we don't talk about this a whole lot, and you've never really had this a ton, but these are the 2 things that we're really going to focus on here. For the most part, this is definitely the thing that we're going to focus on today. So we're talking about most of the time tables today and maybe a few graphs along the way. So for the most part, tables. Okay, so how are we going to do this today? What they're going to do is they're going to give you an equation, and you have to basically create a table and complete the table to figure out kind of what's going on in the problem. So this says equation is n equals t divided by 12. And then by the side, it tells you what n and t are equal to. So let's see here. We have n is equal to the number of messages, t is equal to the time. So basically the time divided by 12 is going to give you the number of messages. That's what the equation says up there. And then it says make a table to find out the number of messages in 120, 180, 240, and 300 minutes. So you can see I already kind of made a table. And t, this is what time, we said this was time, and we said this is number of messages. Now you might be wondering what the rule is. A lot of times the rule is the equation. So the rule was what? N, or was it t divided by 12? T divided by 12. I put the rule in there too. So like this column right here is pretty much a column for you to do work in if you need that work. All right, so time, it tells us what it wants us to use for the t's up here. So we're just going to go ahead and fill that in. Okay. And then we're going to take that time. So if this is t, this is a t, this is a t, this is a t. We're going to take 120 and divide it by 12. And whatever the answer is, that's going to give us the number of messages. So 120 divided by 12 would be 10. So what this means is for every 120 minutes is we get approximately 10 messages in that 120 minutes. So then we have 180, and we're going to do the same thing there. We're going to substitute 180 in for t divided by 12. 180, let's see, 180 divided by 12 be 15. Same thing here, I'm going to do 240 divided by 12. Well, I know that's going to be 20. You can see a kind of pattern. It's going up by 5. So I bet 300 divided by 12, I bet it's 25. Let me do it on my calculator. 300 divided by 25 is 12. Oh, timeout. Oh, I'm sorry. 300 divided by 12 is 25. There we go. All right, so we just made a table for this equation. So what we did is we took that equation and turned it into that table. So kind of what we talked about in the 4 ways you can show an equation, we turned it into a table. Okay, so It's gonna be along the same lines. They're gonna give you a equation in word form. So here's the word form this time. So before, if I flip back, before they gave it to you in the equation, okay, now they're gonna give it to you in word form, and they're gonna have you take it from word form and put it into a table. So this is, and then it says state the domain and range. If you see that, so it's complete the table, state the domain and range. We'll do the state the domain and range last. That has to be the last thing that happens because we're going to figure out our table first. So this is the word format. It says the team scores 6 points for each touchdown. So the first thing I do is I got to find my rule, like what's going on, okay? Do we know how many touchdowns there are? We really don't. So you could take the number of touchdowns times 6, and that's going to give you the total points. You can see what they're looking for. They're looking for like the total points of something would happen. So T times 6 touchdowns times 6 equals the total points. All right, so right here it says the total, here it says the number of touchdowns. If I have one touchdown, how am I going to figure out how many points that is? Well, I'm going to take, and I'm going to put 1, and I'm going to take that times 6, and that's going to give me my total points. So I'm going to take 2, and I'm substituting for T, and take that times 6. So 2 touches is going to be 12. Notice how it doesn't go in order. I go 1, 2, 5, 7. So 5 times 6 would be 30 points. 7 times 6 would be 42 points. So you're basically, this column is telling you what it wants you to put in that equation or that rule, and the Y part, or this part over here, is telling you what it wants for an answer. Now, if you had a state, domain, and range, here's your domain. Here's your range. That's all for creating this table. All right, let's try another one. It says Bob spent 5 more than 3 times what Anna spent. Okay, so first of all, we have to write our equation. Bob spent 5 more than 3 times what Anna spent. We have to find our keywords. Keyword. Keyword. Okay, so what's most important? Well, the most important thing is the times. If you think of Please Excuse My Dear Aunt Sally, the times is the most important thing. So do I know what Anna spent? I don't. I don't know what Anna spent. So we're going to make what Anna spent, we're going to make that a variable because we don't know what she spent. So I'm going to use A just because I like the letter A and it begins my name, so I'm going to stick with A. So for this, it's 3 times what she spent, so 3 times A. And then more, we got to look back over to the more. The more means addition. So there's my rule. Okay, so there's my rule. And I guess I could write it over here. Equals what Bob spent. Okay, so now I'm going to go back over here and say, okay, if Anna spent $2, I'm going to put that 2 in for my variable. And I'm going to get out what Bob spent. So 3 times 2 is 6. 6 plus 5 is $11. So if Anna spent $2, Bob spent 5. So I'm going to do the same thing with 4. If Anna spent $4, I'm going to put my 4 in for my variable. I guess I should make this A, probably, because that's what I'm substituting it in for. Plus 5. So I have 12 plus 5 would be $17. Same thing here. 3. If she spent $6, I'm put 6 in for my variable, plus 5, 18, 18 plus 5, 19, 20, 22, $23. And if I'm going to put for 8, so 8 I'm going to put in for the variable, plus 5. So I have 24. 24 plus 5 is $29. And I have my table filled out. Basically, it's kind of what we did the other day when we had the photographer problem. It was, there's a flat fee. If so-and-so buys 6 portraits for $6 each, how much does it cost? That's basically what we're doing now. We're doing the same thing, only we're just doing many different portraits, or many different times we're putting something into our equation. Another thing you can look for is if you have, and if you have to name domain and range too, you can do that. But if you are looking over here, and let's say you have a constant going on, you're going up by 2's over here. So it's going by 2, 4, 6, 8. This over here should also have some kind of pattern to it. And if you look at this, every time it's adding 6 to it, if you look really closely. So that's another thing you can look at. If you're like, oh, I have a pattern here, I should have a pattern on the other side. And if you don't have a pattern going on, then it's something's not working. If I go back to this one, there's really no pattern over here. See how it goes 1, and then it goes 2 to 5, and 5 to 7. there's no pattern that you can see going on here because this side doesn't have a regular pattern going on anyway. So if it does, if this side doesn't have a regular pattern going on, your Y side will not. But it's a good way to check yourself. If it does, you should have something happening between the two. Okay, so the next part I'm going to talk about is guess the rule. Okay, so we're going to flip it around. This time, they're not going to give you a word format. They're not going to give you an equation. They're going to give you a table, and you have to make it into the equation. Okay, so we have to look at our table and say, okay, what's going on? Well, how do I get from 1 to 4? Well, a lot of people would say, well, you're going to add 3. Okay, that works. But does 2 plus 3 give you 8? No. Does 3 plus 3 give you 12? No. Okay, so that doesn't work. The rule has to be consistent throughout. Okay, so let's try another rule. We thought it was plus 3. Nah, it was not plus 3. Well, how do you get from 1 to 4 now? Well, 1 times 4 is 4. Okay, so we said 1 times 4 is 4. Is 2 times 4 8? Is 3 times 4 12? Okay, so it's something to do with times 4. So what's happening is you're taking whatever's in your X column and you're multiplying it by 4 to get what's in your Y column. So that's my equation for this. I'm taking whatever's in my X column, so whatever's in here, and I'm taking it times 4, and that's giving me what's in my Y column. So I'm just going to throw another one out there. I'm going to quick do one. So let's do X and Y. Let's do okay, so this is a pretty simple one. What's the rule? Somebody would say, okay, maybe I'm going to multiply by 6. That works if I multiply 1 times 6. What about 2 times 6? Does not equal 7. Okay, so I know timing by 6 is not the correct rule. All right, so now you say, well, maybe it's 1 plus 5. That gives me 6. Does 2 plus 5 give me 7? Does 3 plus 5 give me 8? Does 4 plus 5 give me 9? Okay, so you found a rule. Something is going on there with 5. So for the rule, you take whatever's in your X column plus 5, and that's going to give you whatever's over in the Y column. All right, so then they can get a little more complex. Let's look at this one. Okay, so you're maybe thinking 2 to 5, 3 to 7, 4 to 9. Well, let's start guessing. So 2 plus 3. So maybe we'll try 2 plus 3. That gives me 5. Does 3 plus 3 give me 7? No. Something is not right there. Okay. And I can't take 2 times anything to give me 5. I can't take 3 times anything to give me 7. And same with 4. Well, here's the thing. You can have rules that have 2 steps to them. So like for this one, if you look at it, I know 2 times 2 is 4, but then what do I have to do to get to 5? I have to add 1. So let's try 2 times 2 plus 1. Let's do the same thing with here. Let's try 3 times 2 plus 1. That gives me 7. And this would be 4 times 2 plus 1. That gives me 9. So you can see you can have rules that are a little bit more complex. So for this one, it would be 2 times whatever's in your X column plus 1 is going to give you what's in your Y column. Okay? 2 times whatever's in your X column plus 1 is going to give you what's in your Y. So let's say we have 6 in the X column. I would take 2 times 6 plus 1 at 13. So if I was going to continue this table, if I had 6 on that side, 13 would be my next one. If I wanted to figure out what 5 was, I'd do 2 times 5, plus 1. I know 11 would be the next one if I continued my table. So this rule can help you figure out many more things, not just what's in the table, but if you were continuing your table, it could help you figure things out. And ladies and gentlemen, that is my lesson for today. A little longer than I like, but it's kind of tricky when you're doing big tables and like this and stuff. So if you have questions, seriously, write them down for me, and I'll get back to you the next time we have class, okay? See you then.